Okay, take note that carbon is from group 4 and it has a 4 valence electrons. Depicted on these circles are the number of electrons shared or bonded. This is to conform to octet rule, which states that there must be 8 electrons in total for it to be stable. Let's take a look at the double band and the triple band. For the double band, we have here one double band which comprises of 2 bands and it has 2 single bands. In total, it has 4 bands. As for the triple band, it has one triple band which consists of 3 bands and one single band. In total, it has 4 carbon bands. One of your classmates have asked about transforming structural formula to molecular formula. As we can see here for an example, a line structural formula, we have here the edges which are encircled by orange line. This edges depicts the number of carbon atoms which can be translated to this figure. Since it has a 1, 2, 3, 4, and 5 edges, it can be translated to C, single band C, double band to C, and another single band connected to C. Then how can we determine the number of hydrogen attached to each carbon? Fill in the bands of carbon to conform with 4 bands in the carbon. So as you can see here, we have the orange line which represents the hydrogen bond. As for this first C carbon, we have here the A1 carbon-carbon bond and 3 hydrogen bonds to conform with 4 total bonds. For this another carbon, we have here 2 carbon-carbon bonds and 2 hydrogen bonds to conform with a total of 4 carbon bonds. Bonds attached to the carbon. For this third carbon, we have here one double band, another single band to a carbon, and a hydrogen band, which has a total of 4 carbon bands. As for this second to the last carbon, it has a one double band, another single band, carbon-carbon single band, and a hydrogen band. For this last carbon, how many hydrogen bonds must be attached to it? Yes, correct. There must be 3 carbon bonds attached to it. As we can see here, we can translate this line structural formula to this form. The same, it has 5 carbons. The double bond on the third and fourth is carried out, and each bond of hydrogen is represented. So if we try to get the molecular formula, we will just have to count the hydrogen bonds attached to each carbons. For this case, it has CH3, since 3 hydrogen bonds are attached to it. We have here on the second carbon 2 hydrogen bonds attached to it. For the third, it has a lone hydrogen bond attached to it. The same with the fourth, and for the fifth, it has 3. So if we can write this, it is CH3, CH2, CH, CH, CH3.